Hi there. I'm pre-recording this because I'm on a long road trip today, and I just wasn't sure if I was going to make it in time for to get on a Wi-Fi. So this is a pre-recorded presentation of my activity in EGP. It's similar. So this is how we started out the year. We had four sub activities. One of them which is site investigation for tidal power on the archipelagos of the West Coast, the Gulf Islands. We moved that to marine geoscience for marine spatial planning because it fit very well in there. But we still did conduct a cruise in 2025. And then the other three are ones which I've shown before, which is we work with Environment Canada on the regulatory processes for disposal at sea, which is required for a lot of the major projects, including major port building projects around the country. So that's kind of very relevant right now. Um, we are working, well, we've just finished a contract with DFO working on how to decide where to put the trawling boundaries around marine protected areas. And that's in terms of sediment being ejected from the seabed and affecting these areas. And I'll show why that is later on. And we are working with the International Seabed Authority on helping to develop environmental thresholds for mining in international water. So the issue with disposal at sea, which is allowed in Canada for clean materials, is that we're constructing up and down the 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 coasts, but as this is showing for the West Coast, there aren't really disposal at sea sites that are convenient to some of these construction projects. Um, and so companies propose new disposal at sea sites, and we assess their license based on the oceanography they've collected and that sort of thing. At the same time, we realized that we didn't have all of the oceanography that we require from them, and so we also are each year sort of choosing new sites for us to understand our own oceanography of our own sites. The idea is that now we of course have research ships to do this with, and we use big heavy equipment with heavy train wheels for anchors. The idea is that we make this smaller so that companies can do this kind of EA work with smaller vessels, and we have to come up with. I mean, the reason we do it with the big science equipment is that we were trying to find the most robust kind of techniques to define the sites. Um, one of the stations we looked at in the last year was the Malaspina disposal site off the west coast of Canada. And I'll just say that, so our definition of dispersive is if 99, if, sorry, the top 1% of speeds is above 0.25, which would be about here. In this case, the top 1% of velocities is around 0.175 meters per second, 17.5 centimeters per second. So in this case, we define this site as non-dispersive, and we do all sorts of work as well, looking at sediment resuspension and backscatter and things to determine that indeed the higher velocities, which are shown in red here, don't necessarily correlate with kind of resuspended sediment. So these high peaks of sediment concentration aren't all red. This is just another way of showing it. This would be where the basically 99th percentile would be dispersive. Ours 99th percentile is down here. So this is a non-dispersive site. Now, I did mention that we would need to define methods that a company can use a smaller vessel for. And And in fact, we had a chance to do that ourselves. We were asked by Environment Canada, based in Quebec City, if we could do similar work out here in Gaspé Peninsula, um, where there's been hurricanes affecting the disposal sites and that sort of thing. Um, so we're looking at that, and we had a small vessel provided to us by PSPC through Environment Canada, a really unique vessel actually, because it's a small vessel but with a large A-frame, which is exactly what we need. This is Tom, our technician out here in Pacific, who went out to deploy these instruments. And it is interesting because we were looking at very small packages that small boats can provide, but we need more of them to do the same amount of work. I mean, we achieved it with these are all hand deployable sort of packages, but we needed more of them rather than one big, large mooring from an oceanographic research ship. But success, he'll be picking up the package in 2 weeks. And these go to reports directly to Environment Canada by us, and they report on to different uh, involved First Nations from the areas, as well as to the International Maritime Organization in London, under our obligation to report these types of things to that body. Now, I'll start these. This is on setting trolling limits around MPAs, and I'll set the stage with a nice video from David Attenborough. Now, another program of ours provides information about where these fragile ecosystems are, and it's a specific type that we're looking at is glass sponge reefs. This is a map recently provided by this other NRCan program of where these are in the southern part of British Columbia. But previously, we were aware of very large reefs in the northern parts of British Columbia, and those ones have already been protected from fishing. So the question is how on the reefs, but the question is now how far around the reefs should the fishing boundaries be set in terms of these sediment resuspension events. Now, and the reason for that is that this is work done by the University of Calgary, where they set an ROV on one of these reefs just for a few hours, and they noticed that small resuspension events could lead to decreased respiration of water pumping by these rare glass sponges. So they feed by pumping water through themselves constantly, and these small increases in sedimentation can lead to decreased pumping by the organisms. Larger increases can lead to even more pronounced decreased pumping. And so, as I said, that was sitting there for a few hours. So the question DFO had for us is naturally just how many of these kind of sedimentation events occur throughout the year, these increased concentration events, and how would that compare to sort of sediment that's resuspended by trolling. And we had provided to them in 2014 some calculations on the distance that sediment can travel during trolling. But this whole idea of this new work is to try to prove some of this with measurements. And we did a very good job of measuring sediment concentrations throughout the year, or at least sediment events. My report does indicate that we see events of this size and magnitude often, and even larger. And so naturally, these kind of events occur. However, I do want to mention that we lost our main instrument, which is this one here. And you can just see what bad shape it is, but I had to deploy it. It's been on a capital list for 5 years. And so I have the data to show that there are sediment events, but I can't really calibrate that to concentrations, which is a real shame. And that's a bit of a plug for another one of these instruments on this programs capital list or any program, any capital list. We use this instrument for many different programs, and we knew it was on its last legs. So we can provide lots of information to DFO, but just not exactly what they need out of this experiment. Now moving on to seabed mining. The area we're looking at first is this Clipperton zone, which is seabed nodules, basically composed of heavy metals that have formed over millions of years. And that's the first setting where seabed mining in international water is likely to occur, and so it's the first place where we're trying to set these guidelines for. The reason is that there will be probably robots wandering around on the seabed disturbing sediment that hasn't been disturbed for tens of thousands of years, and there's several places where that sediment might also be ejected into the water column, either overspill from the ship or through kind of risers that bring it up and down. There's a group of 35 of us or so working from around the world, and Canada, we're lucky to be offered a seat in this, I think. And Sonia put my name forward as a sediment expert, and so I'm happy to be working on this, but it is very controversial, and we're making some progress. We submitted late last year. We submitted the first draft. In the middle of this last year, we submitted a second draft, and then we have until next week, I think, to submit the very final version, which will then be disseminated to public, and that will then go out to so final guidelines are due in the coming weeks. That'll then go out for public consultation and further assessment, and hopefully be released in 2027.